In this video, we'll write the Lewis structure for N2F4 and we'll look at the molecular geometry. Let's start by counting the valence electrons up. This nitrogen, group 15, sometimes called 5A on the periodic table, has 5 valence electrons. We have 2 nitrogens. Fluorine is in group 17, sometimes called 7A. That has 7 valence electrons. We have 4 fluorine atoms. So 10 plus 28, 38 total valence electrons for N2F4. We'll put the least electronegative elements in the center. Those are the nitrogen atoms. So we have those 2 nitrogen atoms. And then we have 4 fluorine atoms. Let's put 1 here, here, and the same on the other side. So we have a total of 38 valence electrons. Let's put them between atoms, and this will form the chemical bonds between the nitrogens and the fluorine atoms. Next, we'll complete the octets on each fluorine atom. Let's put a pair to bond these nitrogen atoms together as well. At this point, we've used 34 electrons. We have 38 valence electrons. So let's just complete the octet on each nitrogen atom. And that's it. We've used all 38 valence electrons. All the atoms here have octets. This is the Lewis structure for N2F4. We could replace the bonds with lines, which might look a little bit neater. Let's talk about the molecular geometry. Because we have these 2 nitrogens, when we talk about molecular geometry, we want to think about a central atom. So let's treat this as 2 parts. Let's look at the molecular geometry on this nitrogen and then this, which will just be the same since it's symmetrical. So we have 1, 2, and then we're going to count this as the 3rd thing bonded to that nitrogen, and we have a lone pair. Let's see what that looks like. So we're calling this our central nitrogen atom. Let's add the 2 fluorines, 1, 2, they push away from each other. And then let's add that other nitrogen and fluorines. That's just one thing. So that we do that, we get this trigonal planar molecular geometry. We need to add the lone pair in. When we do that, it pushes everything down and we get a trigonal pyramidal molecular geometry. So this is our trigonal pyramidal molecular geometry. Let's go back to our Lewis structure. So if we look at our nitrogen right here, we kind of think of it like this. We have this lone pair here, here's the lone pair, fluorine, fluorine, and this goes to all of this over here. We also have the same thing on this side. So we could put that like this here. You can see the 2 purple, the 2 nitrogens bonded together. This is our molecular geometry. Each one of the nitrogens has a trigonal pyramidal molecular geometry. We could draw it out like this as well if you wanted a molecular model, and we'd have a lone pair on top of each nitrogen here. So that's the Lewis structure and molecular geometry for N2F4. This is Dr. B, and thanks for watching.